Okay. Good morning. Good afternoon, everyone. So thanks for joining us. This meeting, as usual, is going to be recorded, and we plan to post this on YouTube following on the meeting. If you want us to make some edit, if something that you think should not be in the recorded transcript, please let us know, and we'll edit it out before we share. So today, we are going to sort of provide more information about how data is structured to start to make it available. Carter prepare a number of prepare presentations and a walkthrough. And so we were planning to have a session going through our currently available data set as we have been talking about for a while now. So that's the content. Any questions for this agenda or before we dive in? All right. Carter, why don't you take it away?
Okay, good morning, everybody, or good evening, depending on where you are. So I'm just going to go over what the current status is of our files, our predictive processing data, and I'm going to be just talking about how you guys can access what is available at the moment.
Oh, before Carter, I forgot something
Yeah.
really important. We have two important guests, maybe three today. Alessio and Ariel join us to answer any questions. So maybe Alessio, do you want to introduce yourself really quickly? And Ariel as well?
Yeah, hello everyone. So I'm Alessio Buccino. I'm the electrophysiology pipeline engineer at the Allen. So all the spec sorted data that you're going to be using has gone through a pipeline that I've been co-developing. So happy to answer any questions you have on the processing side.
Ariel?
Yeah, I'm Ariel Leon. I work primarily on building the processing pipeline for population calcium imaging data. So any of the multiplane imaging that you'll see here has been processed by the pipeline that I've developed with Johannes Friedrich.
Thank you. Sorry for this oversight. And Carter, maybe apologize for the interruption.
Yes, they will be good resources to ask if you guys have questions about more bespoke details of the processing that I'm not familiar with. Okay. So can you guys see this? Oh, let me share my screen here. Sorry, whoops. All right, can you guys see this?
Yep.
Okay. So this is what I'm going to talk about today. So basically, you've already been introduced to the data tracking spreadsheet, and you might know some about the differences between how, like the pipeline structural differences between the three modalities. But I'm going to be talking more in depth about that and how it relates to you guys accessing our data, updating you on the status of our data, and then actually how to, view the files we have on S3 that's publicly available, view the metadata, view some plots, and opening the existing partial NWB files that we have. So let's see. Okay. So this is basically how our processing is structured for the three modalities. Each of them, we have three. We have NeuroPixels, Mesoscope, and SLAP2. Each of these starts as a raw asset when we upload it to CodeOcean, which is where we do all of our internal processing. They have some similarities, but they can be rather different across the three modalities. And the idea is each raw session here or asset here represents one session, right? And it's identified by a mouse ID plus a date time that the session happened at. So each box here is one CodeOcean asset or one asset on S3. So for NeuroPixels, after we get the raw, we do the spike sorting with Alessio's pipeline. And then when that's done, we take both the raw and the spike sorted and we reproduce a completed NWB that we upload to Dandy. And there are a few of those that we've already released to you guys that were kind of prototypical. For Mesoscope, it's a little bit more elaborate. They do 3 different processed assets for each raw session. Because each sort of submodality of Mesoscope session, like the behavior video is the behavior and the planar OFIS all get done with different pipelines. And then those get all combined into our completed NWB. And then for slab 2, we basically just produce a process asset and then a completed NWB from that. So importantly, well, I guess, so right now the status of our data is that we're here. So we have all the processed assets for EFIS and Mesoscope. Slab 2, the pipeline is still in development. So we haven't quite gotten to processed assets besides like some prototypical ones that we released to you guys. But importantly, you should expect that for every Mesoscope session, there would be 4 processed assets on S3, and for every EFIS session, there should be 2. Yeah.
Cardiff, there's a question from Farzaneh in the chat. Maybe you
Oh,
want to answer. Should we not have behavior processing for EFIS and SLAP 2?
So that's a good question. So basically, the way we have it set up is that those do get, I mean, they get processed in a very similar analogous way. It's just that we do that processing when we generate the NWB. For the most part, that processing is kind of just syncing the timing of the behavior information to, the recording information. Yeah, that's pretty much what we do. So it includes like the running speed, and like the stimulus table and things like that. So that's all done for EFIS and SLAP 2. That's all done in the final step. Okay. So to summarize the status of our data, given what that graph I just showed you, basically we've made a lot of progress on the status of our data, but we have a little bit more pushing to do to get those final NWBs. So in the meantime, we want to release what we have to you guys, just so things are transparent. We would really like to share with you the actual files, like the data assets that we use on CodeOcean, including the processing pipeline and the code capsules that we use. As of right now, there's some limitations with this on CodeOcean. So the best way to share the data with you guys is actually directly where the data is hosted, which is on S3. So that's what I'm going to show you today. We would really like to show you guys what we have on CodeOcean. So we've discussed with other people at AI&D, and we would like to give you guys, some of you, accounts to share the code and stuff with you. We just can't give blanket access to everybody for that. But if you are interested in that, we would like to try it out with you guys. And so please let me know or let Jerome know, and we'll see about getting you guys set up with a CodeOcean account. Yeah. What's up, Najafi?
Hi, Carter. So 2 quick questions. So is this CodeOcean something like GitHub?
Not exactly. So to spare you too much complexity, basically CodeOcean is where we host the data typically, and it's where we access the data, I should say, and where we host all of our code, and it actually runs our compute processing. So all of our processing and our ability to actually write our code and access it, and store environments and stuff, that's all handled online with CodeOcean. So it actually has GitHub integration, so it kind of adds some layer of support on top of GitHub. But the important thing is that you can run the code on CodeOcean.
Oh, I mean, it's my first time hearing about it. And then the other question is S3. That was also in the email that Jerome, I guess, sent. What is S3?
So S3 is basically Amazon's web service where they host data. So tons of infrastructure on the internet uses S3 buckets, is what they're called, and you can basically host your own data there. So CodeOcean offers like a UI to access our data assets and stuff. And for the most part, that's what we use at the Allen Institute, is we just use CodeOcean. But behind the scenes, the data is actually stored in files in buckets on S3.
Okay, thank you.
Yeah, so you can still access it through S3 rather than going through CodeOcean. But yeah, so if any of you are interested in actually seeing what we have on CodeOcean, please let us know. We'd like to see about getting you guys access. So for each of our modalities, like I said, we have a lot prepared. For the most part, we have our raw and our processed assets available on S3, which I will show you. An important detail is that all of the process assets, so everything in green here, should have an NWB file with them. We would call them partial NWBs, right? Because like this will just have the NWB that contains the planar OFIS information, and this would just have the NWB that contains the stimulus information and the running speed. So that information is available. It's just that without it, the NWBs, that information being aligned and combined in one complete NWB, you can't do everything you would hope to do, but it's still a lot of important information that we wanted to give you guys access to as soon as we could. So I will show you how to access those partial NWBs. Another important detail is that the QC is still ongoing for these assets. So it's a work in progress. It's not quite finished. So we might reprocess some assets. We might decide that some assets don't pass our internal QC. So just keep that in mind when you're looking at the data. And if you spot any issues, feel free to let us know. For neuropixels, we're still imaging the brains. So that's one reason we haven't packaged those to complete NWBs. So the CCF, the brain region coordinate location is not available. For Mesoscope, one of the things we're still working on the QCing for is there's a few files that have truncated running data. So you'll notice that on some files if you look at the running. And for SLAP2, like I said, our processing pipeline is still being developed. But on S3, this is what you could expect to see. So everything in red here is stuff that's not yet available for most assets, but the black is what you will have access to. You can see every modality has their raw session asset, which is identified by the modality, plus the mouse ID, plus the date time. For SLAP2, there is no modality. That's because we use a newer schema for SLAP2. Just kind of technical reasons. And yeah, so you can see there should be 2 assets available for neuropixels and then 4 assets available for Mesoscope. And then just the one for SLAP2. Another detail is that the 3 process assets for Mesoscope at the moment have the names all have processed in them. So you can't distinguish them just by the file names alone. You'd have to actually look at what data is available inside the folder. So yeah, keep that in mind as well. But yeah, for the process assets also, you can see they basically are named according to the raw asset with that date time and everything, and then the date time that it was also processed. So it would include 2 date times. Is there another question?
Marcel, yeah.
Yeah, thank you. Sorry, I didn't fully get why we have 2 raw files for the neuropixels.
That's a great question. So the coordinate information, the common coordinate framework relies on our histology and brain imaging. And so that happens typically long after the session, like at least weeks or months after we run the experimental session and we do the brain imaging histology. So for every mouse, we produce a raw CCF asset. And then that can be used in conjunction with the spike sorted, like the output from Kilosort, and then you can basically append the CCF coordinates for all the probes that we inserted.
Okay, and is there also access to the local field potential somehow, or is that contained in the raw data?
That's definitely available in the spike sorted output, so I can show you that in a little bit.
Okay, thanks.
It's also available in the NWB file. We do store a downsample version of LFD.
Yeah. So are there any other questions about this overview? I know there's a lot of information here, but the key takeaways, these are how the files are basically named and organized. Okay. So now I'm just going to show you actually how to access the information, given what you just learned. So let's see. So Jerome has already showed you this spreadsheet, but I'll just review it a little bit. We have every session listed here. We have their modality, the dates, the operators, things like that. The important column I would say for you guys to actually identify sessions is this one. So this can be treated like the identifier of the session. And it corresponds to what the name of the file will be on S3. So this is actually where you get the information of what session is what. You see some of them have the modality name, some of them don't. You don't need to worry about that. Typically the ones without the modality are SLAP2 because they are newer. Let's see. So for those who do get access on CodeOcean, these columns will be important, but basically know that all you need to know is that each ID here corresponds to one folder on S3, so one asset on S3. So like I said, we would produce one raw session asset for an EFIS session and then one process session. And then ideally, we would end up with a completed NWB asset as well. And then for the Mesoscope ones, we also have a behavior and a behavior videos process asset as well. And those are here. These IDs are useless to you unless you have CodeOcean access, but I guess you could treat these columns as information telling you whether or not you can expect to find the corresponding information on S3. So like, for instance, all these sessions don't have a process asset on S3 at the moment. So you wouldn't expect to find one there. But when you're actually looking on S3, this is the identifier to use. So I have a link here also. So S3, because it's an Amazon like web services tool, it's like there's tons of publicly available tools to access S3. So you could use whatever you prefer. You could use AI to write some stuff for you to access S3 however you want. But what we use internally to view our S3 buckets is this one called Quilt. So I just opened this to the bucket that AI&D uses for our public data. It's called AI&D Open Data. And this is all of Alan's, this is all of our public data assets right now. So there's 40 pages at least. Most of it probably won't be, might not be of interest to you, I'm not sure. But what you will hopefully certainly be interested in is the ones from predictive processing. So if I were to just copy this identifier for an ECFIS session, paste it into S3, I can see, okay, this one I generated a few different NWBs for because this was one of the ones we released early on. But the main ones here are the raw session and the sorted asset. So just to give you guys a little tour of a raw asset here or a session, pretty much all raw sessions have these three main folders. They'll have the behavior videos folder, the behavior folder, which includes things like all the data for synchronizing the stimulus regimen and things like that. And then there's the actual recording, like the modality recording folder. So here it would be EFIS, and an OFIS asset. This would be like a multiplane OFIS folder. And then the other thing all of our assets have is this set of metadata JSONs. So this just describes the data asset itself, and it includes things like tons of information about what the actual configuration of the rig were. It includes a JSON describing the subject that was that was used for our experiment. Procedures is basically the procedures done with the subject prior to the experiment. So things like surgery is included in here. Processing is what's done to process the data after the experimental session. So it's basically all of our software. Data description, it kind of describes at a high level overview, like the project that the experiment is tied to. So the funding source, institution, I think investigator names are in here, yeah. And finally, there's this session JSON, which describes all the metadata we have about the experimental session itself. So, well, there's quite a lot in here. But for instance, it talks about rewards consumed, the session start and end time, the rig ID that was used, and then it includes a lot of information about the stimulus. But because you guys have been working with our NWBs, it's probably most useful for you to just look at the NWBs. But this metadata might be useful for you if you want like a high-level overview of the session. And so our process assets also will have this set of metadata, but it might look a little different between a processed and a raw asset, right? Because some processing happens. So at least this JSON might be different. Okay, so for the actual data folders, behavior videos, this includes MP4s of the eye, the face, I think the full body of the mouse. Behavior, there's a lot of stuff in here. Maybe the most interesting would be this stim epochs CSV. This is basically the stimulus table that ends up in the NWB. There might be some differences, but you can see here it includes sort of all the parameters, and then the rows are over time. Let's see what else. Oh, we have a similar table for the opto tagging. Yeah, and then some of this stuff is more bespoke. It would be take a lot longer to explain in detail. Okay, and then we have our EFIS information. So ECFIS compressed is the more important one here. ECFIS clipped is like a small sample of the session. But EFIS compressed is basically the actual recording information all compressed as a ZAR. So it has both the action potential, the AP, and then also as the LFP for each probe. Now, you could spend time digging into like these files directly if you want, but like I pointed out, the process assets all have NWBs in them, and they are more or less the same format as what you guys already expect from the NWBs you've looked at. So if you're not interested in doing a deep dive, I will just recommend looking at an NWB directly. So let me get another session, and I'll show you the NWB. Okay, so we have a raw and a sorted asset for this session. If you click on the process, the sorted one, there's a lot more information. It basically has, I think it has everything that the raw asset has and more. So it has the metadata. And then there's NWB folder. So it's basically all the EFIS information recorded or already processed and packaged into this NWB. Let's see. A few additional things in the spike sorted asset would be, so there's a post-process folder, pre-processed. I think the pre-processing is like drift correction, I think, or motion correction, and then post-process is like annotations, I think. Is that right, Alessio?
Yes, that's correct.
Okay.
Yes.
Okay. And then there is a visualization and quality control folders that might be interesting to you guys. So if you look at quality control, there's like a drift map, a firing rate across the session for the whole population. Yeah, so there's a couple of things. There's like a unit yield plot. And then the visualization. Let's see, you can see for each probe. Yeah, there's also a drift map, and then there's like traces for the whole session. So if you want like a, just highlight, if you're just looking into files and you just want to kind of get a high level view of the file, yeah, look at those quality control and visualization folders.
Yeah, also, sorry,
yeah.
Carter, if I can, there's a visualization output.json if you scroll down.
Yeah.
And that has like these shareable links. Yeah, there's a JSON view. If you click on one, can you expand one of those? You can just click on the sorting summary link or the time series, and this gives like just links that will appear on your browser, and you can actually explore the spec sorted outputs, and these will automatically fetch the data from S3.
Yeah, that's a great point. Yeah, this is a very thorough and advanced like portal. You guys could look at the actual units, and you can view different properties of the units, all kinds of stuff. So if you want to do a deep dive here into this and you have more thorough questions, Alessio will be the one to ask. Yeah, Farzaneh?
Okay, so sorry if the question is a bit too naive, but if I want to access this page, is it like I need to, anyone can access this page?
Yeah, this should be public.
Okay.
So yeah, that's why I'm showing you this quilt view of S3, because this is our public bucket. So this should be publicly available. This Fig URL portal, I believe, is publicly available.
So we need to go to S3 and then search for aimed open data.
Yeah. Or I will share these slides too, so you
Okay.
can go to this link too.
Okay, thank you.
Yeah.
Correct.
Yep.
Sarah has a question. Is there a document to understand the label, etc.? For instance, SUA or PSUA.
Oh, like these?
I'm guessing
That's a question for Alessio, I believe.
Yeah. So this is mainly the curation part, and actually curation is not enabled for like external like to the Allen, and actually we're updating the way we're doing curation. So there is another tool that will become available soon for actually doing manual curation, but this like noise is noise, MUA is multi-unit activity, SUA is single unit activity, and those P1s were like just there for saying, okay, I think it's a single unit activity, but I think it's a putative one. I'm not sure, right? But again, we generate this curation tab, but it's not supposed to be used. Actually, you can use it, but then you can actually download the curation file. But it's not the recommended workflow right now. If you're interested in like manual curation or understanding more about curating this data, I can show in a follow-up meeting some other tools and some other strategy. We'll also have some automated labeling, as you can see there. I will also drop a link in the chat because we recently published the IFIS pipeline, and so there are all the details that you would need to understand what's going on.
Yeah. I do have another question for you, Alessio, which is, what could you do here? What is there information available here in this portal that isn't in the NWB?
No, everything gets all the columns that you see here, and also in the quality metrics tab that you have on the top there, they're also saved to NWB.
Okay, yeah, great.
So everything should be available from the NWB file.
Yeah. So this tool is a great tool. One of the ways you could look at the EFIS data. Any other questions about this?
Yeah, I'm just because Sarah sometimes is not able to turn on the video. She said, I would love to better understand the classification and criteria. I'm assuming that your publication is sufficient, Alessio, to answer that, or? Yeah.
It is. So this is like just in a couple words. So we have a pre-trained classifier that was trained on uncurated data, and it's run first to detect whether a unit is pure noise or neural, and then to further classify single unit activity versus multi-unit activity.
Yeah. Yeah, and I mean, if you are interested in getting CodeOcean access, we could talk about that too, and you could see, more specifically the code that goes into generating these. So that's something we could also think about. Okay. So to continue on, probably for most of you, the most interesting file here will be this NWB. So you can click on here, you can view this. And the last thing on this slide here is this script I made. This is available on the website, but I have it pulled. It basically, you can just give it one of these folder names from S3, and it will open the NWB for you. So I made the script. I'm running it here. I made it with AI pretty quickly. So I pasted in down here at the bottom, just this folder, this sorted folder. It will search in the folder for an NWB, and then it will find what it needs to open that, if it needs ZAR or PyNWB, and then it will open the NWB for you. Like I said, S3 is, I mean, this is AWS's service, and there's tons of tools online to access S3, so you don't have to use this script if you don't want to. You could use a number of other things. Yeah, you can also download the file off of S3, but here it's just streaming because it's a little bit faster. So it's just opening it. Takes about a minute usually. This won't work if you pasted one of the raw assets, because the raw assets on S3 don't have NWBs in them. It's only the processed ones. So the sorted ones, the behavior videos, I believe. And like the POFIS assets as well. Okay, I'll come back to this. Usually takes a minute or so. So that's what you want to do if you want to look in the eFIS information, but you can do the same thing for OFIS. So on our spreadsheet, we filter this down. So here's our Mesoscope OFIS sessions. Here's the name of one, so I could search this on S3. And you see what we expect, which is 1 raw and then 3 processed. Like I said earlier, unfortunately, there's not really a way to distinguish which is which by the name. So you have to just press it and look inside. So this one appears to be the behavior videos because it has eye, face, nose folders. So this will just have, I mean, there's not too much in here. It's basically just like processed average images from the videos. And then there's metadata describing it. If I click on the second one, this one appears to be the planar OFIS asset. So if you see the plane names, that's how you know this is the OFIS asset. So each of these folders is a different plane, and you could actually click on it to see the data. I'll do that in a second. There's also all the associated metadata. Let's see.
Carter, there's a question from Farzaneh in the chat.
Yeah. Sorry, for some reason they're not popping up for me.
Yeah, no, it's okay. So okay, unless you responded. Okay, don't worry. I just will go.
Yeah, so our AWS bucket is supported by AWS open. So we have a team that dedicates support for Open Bucket for the community, and so this is why it's public, and it's gracefully funded by the Amazon actually, which support the dissemination of its scientific efforts.
Yeah.
Okay, but to see these data on S3, so I don't need, because I was logging on AWS through that find this, so I don't need to go through that.
No, but you wouldn't. If you were, for instance, if you were to build a compute infrastructure in the cloud, you would need to start, have an account. If you download the data locally, you use your local compute. We do want to create a few. We don't want to try out creating a CodeOcean account for some people in the team that want to try it out, because this is like completely in the cloud, and so then we would sort of probably give a little bit of compute to try it out.
Okay.
Yeah.
And to access these files on S3. So I thought I have to go through AWS account. That's why I started creating an AWS account, but you're saying no.
Yeah, notice I'm not signed in here, so I just clicked the link.
I see.
Yeah.
Okay. Thanks.
Yep. Well, let's see if that opened up. Yeah. Okay. So yeah, it took 2 minutes. Like I said, I just pasted this folder name and then it opened the NWB that was in the folder for me. So you can see this has the units table, has the metrics from it and stuff. I think the LFP is in here somewhere too. Yeah, under processing eFIS, you can see the LFP and it's got the traces over time. So yeah, the behavior information is not in this NWB yet, but this is a good jumping off point if you want to just look at the eFIS. Okay, sorry, back to the OFIS. let's see, we have vascular. This is the corresponding NWB for the planar OFIS. It's got nwb.zar just because it's stored a little bit differently, but my script will work just as well. So I'll try this as well. If I paste this in here. All right, I'll come back to that in a second, but that will also open up, I think. And so, yeah, the main folders here are these plain folders. So if I go to viz p0, it has tons of information. It has, I think this is the max projection image. It has motion correction, D-crosstalk, has DFF, the classification. And then there's movie QC, which has tons of photos or images, excuse me, that all have different metrics. Let's see. So this is like this is like Z-drift, for instance. Yeah, so if you want a high-level view of our sessions here, you can look at these. I think this is the classifier. Yeah, it's showing basic segmentation. So if you have more questions about this, Ariel will be the one to ask. But yeah, this is very information rich in here too. Okay, that didn't work. I'll fix that. I think it's probably because it's nwb.zar. So, but like I said, you can also use your own tools to find this and open them. I think you could probably just paste this whole path into the script too, and that would work as well. But you'll be able to explore the NWB. And this is actually, because it's a ZAR folder, you can actually open it here because it's structured just like nested directories. So you can actually view, this is actually the NWB file here. So it looks a little bit different when you're viewing it in this view than when you open it with like PyNWB or HDMFZAR, but all the information is still in there. So there's this processing, there's these folders here, which has the DFF, NeuroPill has the images and the segmentation. There's devices. What else might be interesting to you guys? Yeah, there's subject information. So all that good stuff. Okay, so that's what a OFIS session looks like. Is there any questions about this? Okay. And then last but not least, we have our SLAP 2 session. So I will filter this spreadsheet again. Like I said, this is the identifier of the session. Don't be confused that this one has the name and this one doesn't. That's just how they're stored on S3 for kind of legacy reasons. So if I were to copy, let's say this one, we expect to just see the raw session. Like the other raw sessions, it has a behavior videos folder, a behavior folder, and then it has the actual modality recording folder, and then it has the main metadata JSONs in it. They look a little bit different. So in the older ones you saw there, this was named rig JSON. Here it's named instrument JSON. And it was named session JSON in the older ones, and here it's acquisition. They're just using different metadata schemas, but essentially all the main information is still there. So don't be confused by those differences. It has things like data streams and like a emission wavelength, like so a lot of thorough information about the session that we recorded. Behavior is a little bit different. These were run with HARP, and so they are emulating sort of a different file structure than our EFIS and OFIS ones are. So it's going to look different, but we have code to handle this too. If you have more questions, I can work with you on looking at that. And then under our SLAP 2 folder, you might expect this dynamic data folder, and then sometimes there's a static data folder. And the dynamic data, this is actually just the imaging data from the session. So it's structured a lot more simply than the other ones. And then there's an image here too, yeah. So sometimes you can see the images of the recording. So yeah, SLAP 2 is a bit simpler just because it's just only the raw at the moment. But yeah, so to summarize, the basic workflow is you can go here to our spreadsheet. You can look at this column, the CodeOcean or new session ID column, and then you can go to Quilt, or you could use any number of other tools you want on S3, and you can search for the corresponding file. And then at that point, once you can actually see the folders and the data, then you can do whatever you want with them. Basically, you can download them, you can stream them. I don't believe you have write access, so I guess you can't do whatever you want. But yeah, so that is the current state of our files. Are there any other burning questions? Yeah, what's up?
It's less of a burning question and more of a suggestion.
Okay.
So it would be really helpful if we can, for a few minutes, do all of this together, because I'm really, I managed to go to where I see Allen Institute for Neural Dynamics. There is a thing by Saskia and David Feng, but it keeps saying S3 this, and I don't know how to access it. So if we could spend a couple minutes, I don't know if that's okay. Or maybe, yeah, but I'm dying to get access to here. But I don't manage to. But how is cold data related to S3?
Yeah, I think that probably is a good use of our time. What was that, Jerome?
Well, I just say, like, why don't you just put the S3 link in the chat, and then let's just walk it again from the beginning.
Yeah, let's do that.
Awesome. Thank you. And then what surprises me is that there is this tutorial, but then in that tutorial, it just says all data is stored here, S3 and open data, but then it doesn't say how I can get to that S3 open like that. I feel like that should be in the tutorial.
Why are we doing it right now, doesn't it?
Okay, so is this the view you see when you click on the link?
One second. Yes.
Okay, great. Have you been able to access this spreadsheet? I can send it in the chat too. And like I said, I'll post these slides on the forum as well, which will have the links.
Yes, that too.
Okay. So I think you could filter, like you want to look at an EFO session?
For instance.
Yeah, so I think we could change this here. Let's get rid of slab 2. All right, so what I'm going to do is I'm going to copy this session ID here on row 67. And then I'm going to go over to Quilt, and I'm just going to paste it in the search bar. So hopefully pasting that shows the corresponding assets here.
Mm. It did not find it for me, but I searched for.
Oh, really? Oh, is it this one that you copied maybe?
I got the one, I believe I got the same. I got ECEFIS 8307952026022315031509. Yeah, that's the exact one. So I put it in this search.
Mm-hmm.
I just copied that in this search. Yeah, I don't know if others, but also it does say failed in the spreadsheet. It says failed. I don't know what on the second column of the spreadsheet. Yeah, or maybe I got in the wrong one. Yeah, I got no. Sorry, I'm one below that, so I'm exactly in the right one. Yeah, but that one I don't know if it is showing up for others. But search for me shows no matching packages.
That sounds like a.
I can share my screen if that helps.
Yeah, that would be helpful. That sounds like maybe a different type of error than just a search one.
Okay, do you see my screen now? Okay, I
Yes.
got this. So I'm copying this. And I came here and I put it in this search.
Yeah, I think this is a different screen here. So somehow we
Okay.
made it to a different screen. So
Wait, this is, I'm just clicking on the link you said.
yeah, okay,
And
okay.
then I go here. So I'm,
Okay, I see. Quilt is being confusing here. So go press back.
Yeah.
Back one more time.
This is the one more time.
Yeah, one more time.
I believe.
You
Okay.
need to go back to the bucket. Yeah.
Yeah, so
Okay.
see next to the logo at the top, it says S3/Andy Open
Yeah.
Data. So
Yeah.
that's within the bucket. And I think when you press the big search in the same
Oh,
the
so I
blue
have
search,
to do it here. I see.
well that would be searching for a bucket name. So
Oh,
so go back in. Within the bucket, then the below where it says bucket there. Yeah, that search.
I see. I see. Okay,
Yeah, yeah.
thanks.
Yeah, that top level search I think is searching for like other bucket names or packages or something.
Okay, awesome. And then all the information is here.
Yeah. Yep.
Okay, thank you.
Yeah, of course.
Carter, it might be helpful to discuss a little bit of comment from Sarah.
Mhm.
It would be good to create some examples for script to access specific data. The data is very rich and structured well, but without example, it will be tricky for everyone to dig through everything.
Mhm.
You want to comment on that, Carter? I feel like there's several directions.
Yeah, so the current script, I mean, I think as it is, it opens up an OFIS session, the one I pushed to the website. Um, I guess my assumption is that most of you have already been working with the NWBs that we released, so that'd be the easiest. But is there, I guess it'd be helpful for me to know if what interest you guys have to look at, or if you just want to do something exploratory.
Yeah, I don't know if Sarah will be
Because
able
yeah,
to
there's
answer.
there's a lot of things we could dig into.
That's right.
Yeah.
Well, maybe is Karim here? Yes. Marcel?
Marcel?
Yeah, I have another
Yes, I'm
question.
here.
Or go ahead.
I heard my name. I'm sorry. I didn't mean to interrupt.
Marcel, you go.
Okay.
Oh, okay.
I have two questions. So first of all, once more about the EFIS. So when the local field potentials are in the same file as the spike times, and so for I think for the data paper we will only look into the spike times. Then it would be super handy if it's possible to only download the spike times and not the whole thing at once. So is that somehow possible?
Yeah. So the AP folder, let me go back to this here. So under spike sorting, or the sorted asset, and then should be under spike sorted. There's these AP recording folders here, which has this information. Is this just because you don't want to take up space with the data, like all the LFP?
Yeah.
Yeah.
I mean, I guess this will be hundreds of gigabytes, right?
Yeah, probably. Yeah. I mean, I
Yeah.
think it might be downsampled a little bit, but yeah. So it's these AP folders is what you're interested in, AP recording.
Okay.
Actually, sorry, Carter. I think what you showed before is direct streaming of the NWB files. So it only basically reads the entire structure, but then if
Yeah.
you're only interested in getting spike times and you ask to access them, it's only going to stream those on the fly. So it's not going to download anything on your local machine. I think that would be the best way to access spike data.
Yeah, I think you're right. Yeah, if you don't want to, yeah, it will save you time if you just stream the file using the script I provided, because then you won't have to download anything, and so you could just access directly from the NW. That'll probably be the easiest and most familiar.
Yeah. It might be the case that maybe for some computer clusters or for some computing nodes they don't have internet access. I know at least for our cluster, that's the case for most of the nodes. Yeah. So I guess in the end, I would end up downloading them if possible somehow.
So
And
the
There's
NWB
also
files,
tool.
oh, sorry.
I was gonna say there's tools that can read in part of the NWB, so you don't have to read in the full, all of the probes and all of the LFP signals. So
okay.
I can push that in the chat.
Okay, cool.
And
Thanks.
also, the NWB files that are generated are not that large because they have all the spike times, but for LFP, they're downsampled in space and time. So it's kind of just to give some like profiling. So it's every NWB file is around like 250 megabytes.
Oh yeah, I expected way
So
more than that.
it doesn't have the raw data because
Okay,
the raw data lives somewhere else. So as you've seen before, it has its own asset.
Okay, yeah, this is way smaller than I've expected. And my second question is in the spreadsheet, there's also this dandy column. So I guess you recommend accessing the data via the S3 bucket, but is it also planned to make it accessible with the dandy API?
Yes, eventually. So that's our goal. So
Okay.
Back to here, right? We want to produce these complete NWs that have the behavior and the recording together, so you can do a complete analysis. And we've made a lot of progress towards that. So I think that'll happen relatively soon. But we just didn't want to hold you guys back. We wanted to give you what we have for now. So the dandy path for most sessions, I think pretty much everything but these 6 is empty because they're not quite on dandy yet.
Okay, cool.
Yeah.
Thanks.
Can I just jump in quickly? I think the vision is we give you access to everything, essentially, all of the files that we know of, and then and make NWB files that are eventually released. So with a fixed DOI, so that becomes like a permanent record of the experiment, and that becomes what is part of the data release paper. Like we release Boost NWB with a fixed DOI, and they are the permanent record, but ideally all of the analysis derive from because they're sort of a really fixed in time. And so the process of going from this raw data to this NWB can be iterated because might fix some things that are present in some files and not others. And so that's why it's taking a little bit more time. But what we've seen in the last 6 months is very frequently you guys need access to the raw. Like for instance, Slap2, we constantly wanted to share the stacks or things like that. And so we've done effort to share everything from state 0. Yeah. And so if you want to go back to the raw NeuroPixel data and then check the traces directly there, it's possible. As well as the NWB. So there could be a really rich ecosystem of tools that we built together on top of this infrastructure, but it's going to be a work in progress.
Yeah. What's up, Farsley?
Question. I'm sorry if this was already discussed. So is there an example notebook or code that shows an example use of how to download, like, for example, let's say we want delta F over F, and like, I know we can, like, I managed to find delta F over F, but then there are lots of things. It's not as easy. It would be really nice to have the very minimum, the foundation, like get the traces, get that. Do we have anything like that?
That is a good question. So a while back, we released NWBs. It might only be for the eFIS ones, though. Or we have these scripts on the website. Let me see. Because that would be a good resource to provide you guys. So I have this notebook here, which is DFF calculation, which takes an NWB, opens it. So this is where the script I just showed you that's where this one ends here. It just opens the NWB. So that's here. And then within that, oh, this is just from slab 2 though, excuse me. So with the slab 2 folder, it could do this, but I guess we don't have one for our multiplane OFAs. So we could make one of those relatively quickly. Also, I think a long time ago, I presented the OpenScope data book. This has, so the NWBs in here. I can post this link in the chat as well, or in the forum. This has tons of notebooks to access NWBs. Everything in here is doing analysis with NWBs and opening them and stuff. The NWBs we're working with might differ in small ways, so this isn't a complete solution, but this would be a really informative spot to look.
And then the directories match the ones on S3 bucket.
This one just takes like existing NWBs, so the code it won't work directly on S3. The ones in here.
Because I guess some of the confusion is like going to the right path. So part of it is, and that would be helpful too.
Yeah, so I can put together a quick notebook that just takes one of these paths and then pulls out like the DFF and stuff.
Right. Thanks.
Yeah.
Yeah.
Okay, any other questions?
I'm now processing plane 4 DFF data, and then there are now some numbers like 0.1, 0.2. I don't even know what those mean.
Okay, yeah, I'd have to look at it too, yeah.
Yeah, we could share, we have some documentation of the file structure into those folders, so we could share that as well. Okay, it's 10:00. I wonder if next week we should go back to the data release paper and try to sort of discuss how to organize ourselves, because everybody's. I mean, there's so many directions we could go with this data, but the intent is to sort of start building a number of first order figures to make the data release paper. And so having access to the data will allow you guys to start. And so maybe you can all sort of explore the data set and then start. Sorry, there's a question from Karim. Yeah. And so maybe next week we can discuss the data release paper and organize ourselves. Do you agree, Karim? Or?
In the meantime, ask the questions you have about the data onto the forum posts, and we'll pay attention to those and help you guys get used to it.
Okay.
That's a great question, Alex. Maybe send us an email and we'll talk about it.
For those that want to try out CodeOcean, yes, send us a message and then we'll set up an account.
Quick question, Jerome. So that would be, and the advantage of that would be what exactly?
So you would have access to how we interface, how we build code that works with those buckets with the compute baked in. And so essentially give you access to our internal. It's like a GUI. It's like a MATLAB on the cloud that work with all of those buckets essentially.
But then, if we can access the data through the bucket, then do we gain anything beyond?
You get access to all of the pipeline code.
Yeah, you can see all of our code, and you get the compute that CodeOcean offers.
I see. Okay, thanks.
But it's something that you have to learn to use because it's like learning a little bit of how MATLAB is structured and how to use it.
Thanks.
Okay. So next week we'll discuss the data release paper and have a sort of an organization discussion on how best to. Does that make sense? Thanks, everyone.
Ready. Thanks.